On these problems for learning objective 11.1, open to a new page, get out your quick reference sheets. You're going to want your references for decoding the names of organic molecules. And as we go along, start pausing the videos and trying them yourself before you see me do it. So this objective is simply adding lone pairs and hydrogens to incomplete Lewis structures. But we're going to keep practicing some of the other parts. So how do you draw something from a name? We look at the root, bute. That tells us how many carbons there are. It tells us there are going to be 4 carbons. So I'm going to bond together 4 carbons in the way we'd write a Lewis structure. Then we've got this suffix, oic acid. It tells us we're making a carboxylic acid. So on one of the ends, either end, I'm going to add the 2 oxygen and the hydrogen that make it a carboxylic acid. All right. Now we can do the question. This is the kind of thing you get in the problem, and now you need to add to it. So you click on a C, and you say, oh, the C should have 4 bonds. It has 1. So to the other 3 bonds, I attach H's. Then I go to my next C. It has 2 bonds. So you know how many H's to add. Click on the C, drag it out. Click on the C, drag it out. Go to the next C. It has 2 bonds. The rest of the bonds are to H. Go to the next C. It has 1, 2, and a double bond, so 3, 4. This C is complete. Let's go to this O. It's got 1 bond to C, 1 bond to H. O typically comes with 2 lone pairs because it brings 6 electrons in its valence shell, whereas carbon only brings 4, so it makes 4 bonds. Oxygen only makes 2 bonds. All right, we go up here. Oxygen has a double bond. That counts as 2. And then 2 lone pairs. So that's how you'd finish out the structure. Now, there are so many possible structures. We just can't cover them all, so we're looking for the trends. I'm going to do the naming here. We're going to look for the root. The root comes in the last name, benz. So that's for benzene. It's going to have 6 carbons in a ring. I don't know if this molecule could actually exist or if it would be stable, but it has lots of good naming stuff for us in it. So we've got the benzene started, but it has benzene is an aromatic compound that has alternating double and single bonds. Okay. Then we've got to do the suffix amide. So you find that on your functional group sheet, and it's got that double bonded oxygen. And instead of an OH like a carboxylic acid, it has NH2. So this is the amide. We've done benz here. We've done amide there. Now we start with the prefixes. This O, this tells us the relationship of the group, of this prop group, to the amide group here. There's O, M, and P. O is, well, you can watch these, but you can learn these elsewhere. But this is next to each other, one away, and opposite. You can look up videos, but we're not too concerned about it. We just want to be able to interpret structures when we see them. We don't need to be able to write the names ourselves. So it's going to attach either here or here. Doesn't matter. It's just the one next to it. So I'm going to connect it to this here. It's a prop group. That means it's got 3 carbons. It's a propine, which alkynes have a triple bond, and that is at the first of the 3 carbons. So from this 1, 2, 3, the one that's attached, make that a triple bond. Okay, so if you had the problem, it would just start out looking like this. And now's where you'd have to start adding to the molecule. You need to add hydrogens and lone pairs. Every carbon should have 4 bonds. This has 1. So we need to add on 3 hydrogen. We go next to this carbon. It has 1, 2, 3, 4. It's done. Go to this carbon. It has 1, 2, 3, 4. It's done. Here, 1, 2, 3, 4. Complete. To the bottom one. 1, 2, 3. Gonna add a hydrogen. Next one. 1, 2, 3. Add a hydrogen. Next one. 1, 2, 3. Add a hydrogen. Now we're up at the top. 1, 2, 3. Fourth is a hydrogen. The carbon connected to the amide. 1, 2, 3, 4. It's done. Carbon in the amide. 1, 2, 3, 4. It's done. Oxygen. It should have 2 bonds and 2 lone pairs. Done. Nitrogen. It should have 3 bonds, 1 to the carbon, 2 to hydrogen, and 1 lone pair. So I draw that lone pair on. So the red is what you would add to your structure to complete this problem.